Hello and welcome to our broadcast titled Scaling Redis Applications with Docker Containers Using Redis Enterprise. It's a pleasure to introduce today's presenter, Shihan Bikalu, Redis Labs Vice President of Product Management. Redis is the #1 database on Docker. Redis Enterprise Pack is the enterprise version of Redis with built-in high availability, higher scale, exceptional performance, and the ability to run on a combination of RAM and flash memory. In this session, Shihan will explore setting up a quick development environment on Windows with Redis Enterprise in Docker, in addition to moving a simple app on Mac OS from Redis to Redis Enterprise with Docker. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. We will be taking questions throughout the broadcast. There is a question and answer feature in the control panel that you can use to post questions, and all questions will be answered in the order that they are received. Thank you for joining us today, and at this time, I'll turn the broadcast over to Shihan. Shihan, take it away.
Thanks, Sharon. Hi, everybody. I'm Gian. I'm VP of Product Management here at Redis Labs, and I just want to walk you through a couple of cool demos today and explain and walk you through the architecture that we've set up with Docker. If you're familiar with Docker, you're going to enjoy a couple of the demos around Redis. If you're not, don't worry. I'll actually do a verbose walkthrough of how we're setting things up and what topologies we're working with today. So let me walk you through the agenda really quick. I'm going to introduce the company very quickly to you in a couple of slides. Then I quickly want to dive into the overview of Redis Enterprise Pack on Docker. We'll look at our architecture. I just want to show what our cluster architecture, our node architecture, and our Docker container architecture looks like, so that you're familiar with all of that before we dive into the demos, where I'll actually show you how to take an existing Redis open source application and point to that Redis Enterprise and get it working using Docker. And if you're using Windows or Mac, I'm going to do a slightly different versions of the two, so you will get to see the experience on a Windows laptop and a Mac laptop that I have set up here. And then at the end, we have some time for questions, but I encourage all of you to make this interactive. So if you've got questions, fill them into the chat window, and I'll try to get to them as quickly as I can. All right, let's get started. Redis Labs, we're home of Redis. We're the commercial company behind the open source technology. We work with Salvatore and a team of open source developers that contribute to the open source technology. We also build a Redis Enterprise platform around Redis. The Enterprise platform is the underpinning for all the products that we ship. And we're a company that's fairly young, founded in 2011 and headquartered in Mountain View, California, and R&D center in Tel Aviv. Now, I mentioned Redis Enterprise. Redis Enterprise is the underpinning technology. We use it in a variety of our products. On the left, you see the services products that we provide. Redis Enterprise Cloud uses Redis Enterprise technology, but provides a completely managed service in public clouds that you're all familiar with, from AWS to Microsoft Azure to Google Cloud. We have presence and a fully managed service where all you need to do is just tell us in which geography and in which cloud you want your Redis database in, and there's not much else that you have to worry about beyond that. Now, the same technology is also available as a private cloud capability. You call this Redis Enterprise Cloud Private. It comes with additional capabilities. You see the Flash logo at the bottom. I'll explain what that stands for in a few slides during architecture. But ultimately, the big difference here is that we can provision Redis Cloud, Redis Enterprise Cloud, directly in your own accounts in the public clouds you operate in. So if you've got an AWS account and you want to own your own data, you can choose Redis Enterprise Cloud Private, and we will manage and configure the entire environment within the boundaries of your accounts. So your data ownership and ownership of the operations stay with you, but we help you manage the entire service there. On the right, you see our software offerings. The same platform, Redis Enterprise, is also available as an on-premise deployment. You can get it as Redis Enterprise Pack. This is where you can take the same software, run it on-premise yourself, or we can help you run it with Redis Enterprise Pack managed if you have a private cloud setting. But in this case, you're getting the product in full, and you get to do all the manageability yourself, except in the managed offering, obviously. But the full set of capabilities are available here as well, and we'll talk about that. Now, this technology is fairly mature, even though we're a young company. Today, we run over 250,000 databases. We have more than 600 databases created every day on our platform, and we've survived through thousands of node failures in a variety of different clouds without losing any data. So this trusted technology is already running fairly large deployments in the public clouds that you can trust. This is another quick view of where our customers lie around the world. We've got over 6,900 enterprise customers on the services side, and over 200 enterprises on the software side. Over 60,000 accounts that we manage on our offering. There's a free tier, so some of these accounts are in the free tier, but they convert into paid customers, in the 6,900 that you see up there is the number of paying enterprise customers that we have. I just want to flash this up quickly just to show you we operate in many of the verticals that you're familiar with, and people build obviously their critical applications on our platform. Many of these are names you will recognize, and they're running their mission-critical platforms either on our cloud offering or our on-premise offering with Redis Enterprise Pack. All right, so let me dive into the technical material here. What I wanted to do first is take you through the Redis Enterprise Pack architecture. Some of the I'll start at the very high level. I'll talk about what the cluster looks like first, and I'm going to zoom into the components eventually, all the way to the shards and the Redis that we run. So we'll start from the cluster, zoom into the node, and zoom into the shards that we run and how they're architected to give you a full view. Okay, let's start at the cluster level. This architecture applies to Redis Enterprise in general. This, you can assume that what you see here is practically what we run in the cloud as well. And the Redis Enterprise architecture is essentially a shared nothing cluster that has a single node type. This makes capacity planning much easier if you need to get additional computational capacity to run more operations over second. You simply just add more nodes and rebalance, and that essentially redistributes the load, and we can reap the benefits of the added hardware in our cluster. This is also a cluster that is fully compatible with the open source Redis. So if you have an application that runs today against open source Redis, you can point that application immediately at Redis Enterprise, and it will continue to work. There's a couple of things that make that magic happen. So I'm going to dive directly into the node architecture to show you how we do this. One of the things that is important to compatibility is the proxy architecture here. The proxy that you see at the blue layer within the node is the layer that manages the connectivity between the application and the cluster. It essentially scales the number of connections that may be coming in. It's also responsible for improving applications' performance by applying certain techniques. There's a lot of capabilities within the proxy to be able to take operations that may be applying to multiple keys across multiple shards and be able to distribute them across. So this is an intelligent proxy, but extremely low latency. We have the red section at the bottom, which is Redis Enterprise Shards. Now, these are very similar to Redis open source in their shape. I'll, in a second, describe what the differences are between the Redis open source and Redis Enterprise shards are. But we use multiple shards per node. As you know, Redis is a single-threaded engine. This allows us to exploit the multiple processors and the processing capacity of a node. This is where the execution of the actual data path happens. On the blue layer, we also expose a secure UI and a REST API that allow you to orchestrate and manage the cluster, and a cluster manager which is responsible for governing the cluster. So its responsibility is to orchestrate failures, detect them, execute a failover, which is a intricate ballet of making sure that the operations can continue and we can continue to serve the data path execution, etc. But it's responsible for all of these operations. It's also responsible for stats collection, alerting, etc. So that's our node. So let's zoom in one more level into the shard architecture. Now, what I will describe here at the top level is not very different from the open source Redis architecture. The shard that you see is a single-threaded engine. Redis is a lock-free architecture. It's built around a Redis event loop. So essentially, through the listener, all the events land in Redis shard. There is a path where if you're executing a data operation, like you're setting a key or adding elements to a set, those are going to go through the left side of this picture through the connection handler, where we establish your connection. Then the command parser will take your command and understand what you're trying to do. And we have multiple dispatchers. Either if you're using the internal commands, there's a command dispatcher capability, and if you're on the left side using some of the new capabilities with modules, the module itself has a dispatcher, excuse me, that will take and execute your command. On the right side, we have background services, so things like expiry, eviction that we have to manage that address the full set of keys that are in the shard. Operations like replication or disk I/O are background services and processes that we run. So this is the process space. If I drill a little further into the storage space of Redis, Redis is in RAM storing keys and the structures that hang off of them directly there. And on disk, we have a capability to save either a snapshot of what you have in RAM, or as you perform operations, we can do an append-only file that captures all the operations you're performing within RAM to be able to recover and replay them. So this is what you see referring to as AOF and snapshots, this durability. So it is an in-memory database with persistence, and the thing to remember here is that it's a single-threaded engine built around the Redis event loop. It's what makes it unique and what makes it so fast compared to some of the other engines. Now, within our architecture, obviously, we engage in each node. You get to control the number of shards, that's the number of Redises that you want to run based on the capacity you have, computational capacity you have on that node. And within the cluster, you can run a large number of these Redis shards to be able to handle very large workloads with high throughput and low latency. There are a couple of differences between Redis open source shard and Redis Enterprise shard. One of the big differences you can see in this picture, the process space looks the same at the top level. But if you look at the storage space, one of the unique things we can do with Redis Enterprise is to take some of your values and push them over to flash memory. This is called the Redis Enterprise Flash capability. I'll show you in the UI how you can enable this, but ultimately the reason to do this for a lot of our customers is RAM is quite expensive for storage. So if you've got very large data sets and if you want to be cost conscious, using Flash as an extension of RAM makes it available, makes it easy for you to set up a very large database for a lower cost. And this capability is a way in which you can store much larger data sets at the latencies that Redis provides, which are really fast. The techniques we use, you can find this in documentation, allow us to be very different compared to a disk-based subsystem. We extend RAM into flash, and that gives us a leg up on disk-based databases, either NoSQL or relational, which have to use disk as a way to store the data. When we use flash, we use it using tricks that allow us to skip the expensive cost of having durable writes. We can actually use flash in ways that allow us to be very efficient and effective in retrieving them. So this is what's unique about it. All right, so with that, what I'd like to do next is switch over to a couple of deployment topologies on Docker. One thing I want to mention before I dig into this section is with Docker containers, we've actually set it up so that a single Docker container contains a single node of Redis Enterprise, which means within that node you're running multiple Redis shards, and it's in your control as to how many shards you want to place within that container. So keep that in mind as you look at the pictures. Now, one of the common topologies that we see with Redis Enterprise deployed using Docker is where customers who want to do local development to have a single host and a single container image so that they can get the full behavior of Redis Enterprise on a scale minimized deployment. A single host obviously means that you're not going to have a production grade deployment here. There's no high availability, there's no replication, but if you're locally developing an application and you want to test against what you will have in production, or functionally want to see and make sure that everything works fine, you can use this topology. Now in this model, you can connect to the Redis Enterprise container either from the host, so you can map some of the ports of the Docker container in the Redis Enterprise directly to the host and just work with applications directly on your host, or you can create other Docker containers that are representing your application and they can connect into the host. So there's a whole bunch of options to choose from here in terms of networking. Excuse me. And I'm actually going to take this and do a quick demo of this in just 1 second after we walk through a couple of the other topologies we have. So you'll see this on Windows, and we'll do this quickly on a Windows laptop. Another common topology, I'll call this topology 2, is to deploy the full cluster on a given host. Some of the customers who actually would love to see the failover behavior and experience the full cluster capability and how we distribute the load would choose to do this. And what you're doing essentially here is forming a full cluster on a single machine. Again, the replication is essentially not there to be able to provide you high availability, but you can simulate what will happen in production, and it's a good way to scale minimize what you have in production into your laptop. From a connectivity standpoint, when it comes to connection to a cluster like this, I recommend using another container that connects as the application into the cluster. So other hosts can also have containers that can connect into the cluster, but this is the way it's exposed, and it's fairly simple to work with. And finally, topology 3 is what you would see in production, where there are multiple nodes that host Redis Enterprise Pack containers, and they're distributed in a way that makes it so that we are not placing multiple containers on a single host. The reason not to do that, by the way, is to make sure that when we replicate to another node, our internal assumption is that there are different domains of failure. So a replicated copy should reside on another failure domain like a separate host. So if a single host fails, it doesn't take down all copies of the data. So in this topology, you're paying attention to the fact that You don't place a replicated redundant copy of your Redis data on a single host. Every host contains one container and is distributed in a way that allows us to take full advantage of Redis replication or Redis clustering, and it's also good from a performance standpoint to actually apply this model, because within this deployment you don't have multiple containers in a single host competing with each other for the resources. Under load, if you're pushing scale and you have high throughput, these engines can have the host and the full capabilities of the host to be able to serve that load, and you have much less jitter, essentially, in the throughput that you achieve. All right, so these are some of the common topologies. What I wanted to do next is show you topology 1 and topology 2 in two quick sets of demos. I'm going to walk you through as to how I'm setting them up, and we'll walk through how to set up a cluster in the meantime as well, through the UI and through scripting. In both demos, I'm going to do one thing in the beginning, which is I'm going to take a fun app pointed at Redis open source and run it. Once we're done setting up our Redis Enterprise clusters, I'm actually going to take the same app pointed at the Redis Enterprise cluster and just run it, just to show you how easy it is to port the application just by changing its connection string only. All right, let's start with Windows. Let me switch over to my Windows machine here. The first thing I wanted to show you is the app that we're going to perform. So this app is a fairly simple app. It really is. It was a long flight, and I had some time. It just outputs the matrix-like picture by using Redis, storing information in Redis. So it's essentially matrix coming out of Redis that we will do. And the step-by-step guide I'll walk you through is also available on GitHub, but I'll walk through all the steps here. So the first step I'm going to perform is to take a Redis open source container and run it on my machine. Okay, so we've got, if I do a Docker PS, you can see that I've got this one container running called Redis OSS. It's the Redis image that I'm running that's very popular on Docker. I'm going to take my app, the simple app that we just looked at, and run this. Now, it's running on remote session, so it's going to be a little sluggish, but this is what the output looks like. So it's essentially storing information in Redis and retrieving it to display a matrix-like set of characters. All right, so this is what we have at the moment. So let's start our Redis Enterprise cluster with the Redis Enterprise container. It's a simple command line. This command line essentially is taking the Redis Labs Redis image. It is going to be mapping a couple of the ports. 8443 is one that I will use to show you the UI. If you want to use the REST API, 9443 is our port. This is when we need to script the actions that we want to perform. And 1200 is where our data access path is going to be set up. So as opposed to 6379, which is the default port for open source Redis, in our case, you can set up your port to be any number, and I'm going to be setting it up so that 1200 is the data path communication here. So let's take this line. Let's run this command line here. This will start the Docker image. So if I do a Docker PS, you will see now two instances running. Redis 1 is now the unique new Redis Enterprise container that we have. To create the cluster, I'm going to go to the UI and walk you through how to do that with a simple set of steps we have. So if you go to HTTPS localhost 8443, you may get this warning because we're using HTTPS and you don't have the certificate yet in your first use. You can simply just continue out of this. We haven't set up anything, so I'm going to walk you through how to set this up. So this first node that's running on my Windows laptop here is going to be the first node of our cluster. This is the first screen in the setup. We're setting up essentially paths that allow us to store a variety of different information. We talked about Redis Enterprise Flash and Flash storage. I'm going to enable that feature right here as well. You see the IP address that you're going to be listening on. One of the pieces of information that you need to provide is a name for your cluster. I'm going to call it cluster.local. That's a simple made-up name that we can use. For simplicity, I won't go through all the options here, but let's walk through how to set it up. The second screen you will see is cluster key. If you're using the evaluation edition, you can skip the screen simply. We're going to set up an administrative account and password that we can use to log in later on to the cluster. I'm going to use my own email address here and Redis Labs 123, my very secure password. With that, we're going to have our cluster set up. Now, let me take you through the screens here. This is a way for you to look at the entire cluster and operations over seconds among a variety of nodes or cluster. You can see the configuration of your cluster and some high-level information here. The number of nodes, obviously, that we've set up is just one. So this is what you're seeing under the Nodes tab. Under databases, we don't have a database yet, so let's create one. We're going to name it DB1. We'll give it 1 GB of information. One of the things that I'm going to do is to give it port number 1200. This is important because that's the port that we exposed for the Redis through the Docker container. I'm going to enable clustering. You can start with a single shard, but you can also increase the number of shards here. So we'll start with 2, given my laptop is not very powerful. And there's a whole slew of options that I won't go through, but this is a fairly simple process. And once you create this database, you have it running. Its endpoint is now listening on port 12,000. All right, so let's go back. We've visited the UI to create our cluster. We've created our database on port number 1200. So now it's time to run the application again, this time against port 1200, so that the application will run against the Redis Enterprise cluster. And not surprisingly, it displays the same output. So remember, we have 2 shards in the background, and the operations are essentially getting sprayed across those shards. So we went from a single shard to multiple shards, and the application continues to operate without problem. So the only thing I had to do was to change the port number here. All right. This was demo 1. I just want to show you demo 2, and the slight difference here is I'm going to do this on a Mac. And the topology I'm going to use is going to be slightly different. This time, we're actually going to set up 3 containers running on my Mac laptop. We're going to form a full cluster with 3 nodes, and we're going to move the Redis application again from the open source to a Redis Enterprise cluster. All right, let's switch over to the application. The application is similar. I won't walk you through line by line, but it's that pretty output that we just looked at a second ago. Before I do a Docker PS, just to make sure that there's nothing running, we have this running on Mac. The walkthrough that I'm going to do is going to start with the same steps. So let me run, for kicks, the Redis open source image. and we're going to run this application, the Redis driver application against port 63789. The output is what you expect. It is just an application that's running a set of get and set operations and displaying the matrix here directly. Now, the next step I'm going to, for us to set up a cluster on a single host, I'm going to set up a network between them first. I want to be explicit about this because when I run my applications, etc., I want explicitly containers to join this network. So let's run this command first and create our network. The next step for us is going to be running 3 containers this time. Now, the commands are very similar but slightly different. I'm going to name them Redis 1, Redis 2, and Redis 3. I'm going to map the ports in a way that allow them to communicate with each other. So they're using the Redis net network that we just created. But I'm also able to communicate to them from the host. I'm mainly going to communicate through this port here to show you what the UI looks like. To get to each one of the nodes, now you have to map them to a slightly different port on your host if you want to do that. Okay, so let's start with the first one. This is the first container we're going to run. This container, when we start setting up the cluster, is going to be the initial host that starts the cluster, and the other 2 are going to join in. I'm going to run the second container to start the second node, and I'm going to run the third container to get the third node up. If you look at the Docker PS output now, you're going to see Redis 1, 2, 3 running, as well as Redis open source. We haven't stopped that container. Now, in this case, let me take you to the UI and show you what we have. Again, going to HTTPS localhost 8443, this is where the UI is rendered. You will see a warning because you don't have the specific certificates on HTTPS. But there's no cluster set up at the moment. In this demo, what I want to do is just show you how to do this through command line. It's very simple. To create the cluster, what I'm going to do is run this on the first node. So this is running a Docker exec. We're running a command called rladmin that allows us to create a cluster. We're giving it a name, the cluster.local name that you've seen in the past, in the previous demo. I'm giving the username and the password here, and I'm going to enable Flash, just like we've done in the previous demo. This line will actually create and initialize the cluster. So if I go back and refresh, now we have a cluster set up. I should be able to log in here with my email and Redis Labs 123 password. If I go under nodes, let me make this a little larger. If I go under nodes, you can see that there's only one node at the moment. So let's continue with our scripted execution here. On node number 2, I'm going to run the rladmin command. This time I'm instructing the nodes to join a cluster, and I'm pointing it back at the 10.0.0.2 node. Now, if you look at the IP address here, that's the IP address of the first node. So this node is going to be talking back to the initial node of the cluster, and it's going to try to join. We're going to see it come up in this screen as a second node if things work correctly. And eventually, the status will turn green when it's ready to be used as part of the cluster. So now it's ready. All right, let's do the same for the third node. It's exactly the same script, except this time I'm running this command on Redis 3 container. Not surprisingly, you should see the same set of events triggered here. And once the node turns green, we're going to create our database as well. Now, in this case, you will see that there is no database created. So that operation is done through the REST API here directly. What I'm going to do is essentially provide the name of the database, the type of the database that I want to create, the amount of memory I want allocated, and the port number. There are many other options that you can pass in, but let's keep this simple. The operation will come back with the full properties of the database that's been set up. If I go back to my UI, you will see now that I refreshed, a sample database has been created. And if I look under the configuration, you will see it listening on port 12,000. All right, we're very close to the end of this. We're going to take our application and we're going to, again, run it against port 12,000. Let's see if it actually returns the same output. Not so surprisingly, you see the same output come out. So the same Redis application that is doing the gets and sets here, let me scroll down here, is essentially going through and doing the sets here, is essentially running against Redis Enterprise cluster, which has 3 nodes and has distributed the shards across multiple nodes. Okay. So I want to quickly recap here what we talked about. We talked about the company, Redis Enterprise platform, and how our products are formed around the cloud and on-premise deployments. We talked about the architecture of Redis Enterprise and how the Docker architecture looks like. We looked at the cluster architecture, the node architecture, and the shard architecture, which is based on the Redis open source but is extended. We looked at common topologies when deploying Docker with Redis Enterprise Pack. And we've looked at 2 of those topologies, one with a single container on a single laptop on Windows, on a Windows laptop, and converted a Redis application to a Redis Enterprise application quickly there. And we also did a quick demo on Mac with multiple nodes running Redis, multiple containers running multiple nodes of Redis Enterprise Pack, and we ported another Redis application there as well. This is what I had for today. I also want to remind everybody that we have RedisConf 2017 coming up quickly in the next 3.5 weeks or so. I encourage all of you to sign up for the conference. And if you'd like to get a hold of me, I'm on Jihan at GitHub or on Twitter or email. You can reach out and I'll be happy to answer any questions you have. All right, let me lift my head up and see if there are questions that we've gotten. I see one that's been submitted here. So essentially it says, I am running many open source Redis instances with Kubernetes. Can I move this to Redis Pack in bulk? And the answer is yes. Docker is the underpinning for the Kubernetes deployments we have. So the same Docker image that you see here is what you can use. And in our case, obviously, we host many Redis instances in a single node that allows for much better connection management and much better scalability. And all of those give you much better manageability and throughput and performance to be able to take advantage of the hardware that you have. So in general, this is a fairly simple thing to do. There are blogs on Kubernetes that you can certainly look at, etc. on our website as well. And I see one other question here. Can I run Redis directly on Windows Server? The answer is yes. So the history of this is Redis on Windows was a project that was sponsored a while back on by Microsoft. Unfortunately, that project is no longer being advanced. There's a number of different options you have today with Redis on Windows. One is obviously you can use the containers. Redis Enterprise Container gives you the clustering capability with a simple setup. And on Windows Server, you have very similar options with containers or VMs that you can run that contain the Linux version of Redis Enterprise or Redis Open Source. The last question I see is, will your image work on Docker Swarm? The answer is yes. Yeah. We don't have quick recipes that I can point you at today, but Docker Swarm is fairly straightforward. Kubernetes, Mesos, Docker Swarm, whichever happens to be your favorite orchestration environment, we've got capabilities that are fairly easy to engage there. So you've seen the command lines and the setup that I've run today. It is fairly easy to repeat. By the way, all of this is available under a single repo here. Let me put that up as well so you guys can look at this. So if you go to this URL, you have the demo 2 and demo 3 that we've looked at today. There's another demo that you can use for setting up automated releases, automated deployments of the Redis Enterprise cluster with Docker as well. So feel free to use this repo as well for entertaining yourselves with Redis Enterprise. This is pretty much it. This is all I had. I appreciate all of you participating in the webcast today. Thank you very much.
Hey, Shihan, thank you very, very much. Great topic, lots of interest, and wonderful demo. To learn more about Redis and Redis Enterprise, register today for RedisConf 2017 at redisconf.com and take advantage of the multiple sessions that are being planned. As a special offer for those who are attending today's broadcast, when registering, please use promotional code RedisHero2017, all one word, to get complimentary passes for the 2-day conference. Again, that's RedisHero2017, and register for free. Thank you again for joining us. An email will be sent with a link to the recording of today's broadcast. For an overview of upcoming webinars, please visit redislabs.com and register. Bye for now.